There you go.
Okay, thank you.
Yep.
Oh my gosh. Like usually I'm fine. I'm like, what's going on? Sorry, you guys. There were some tech issues. We got it figured out though. All right, I'm going to take attendance really quick here. If you can hear me, go ahead and put in the text box yes, so I know for later. All right, I was looking for Ben. He's here. Reed Patterson, I'm pretty sure I saw him. Oh, there he is. Okay. All right. So something new we added on to Google Classroom. I'm going to share my screen with you guys and show you. So if you go to Google Classroom on the classwork, I think videos of the Zoom. So I'm going to pop it up for you guys so you see. I'm recording all the Zoom sessions now, so you guys should have links up here. So if you miss something in class, you want to re-listen to it so you understand it better, it'll be on there from now on. All right, so this is under classwork, and then you just click there, and there should be a link for each day. We will start it. We did yesterday's, and then we will try to get today's uploaded too to make sure. So yesterday, you guys were working in class on partner paper. You guys remember this? Do you guys want to go? Would you like to go over the answers? Why don't you pull out your paper and I'll go over the answers. And then if you guys see someone like one of the ones you want to go over, we can do that. All right, so number one, I'm going to read through these answers and I'll pop it up on my thing too. On to Smart Notes. Hold on a second. All right, here we go. Number one, I have 25.91 degrees. Number two is 8.81 feet. Number three is 1,341.71 feet. Number four is 3,017.82 meters. Number five was 3.79 degrees. Number six was 146.82 yards. Number seven was 19.89 degrees. Number eight was 20.44 feet. Number nine was 57.90 feet. And number 10 was 370.91 meters. If you look at any of those and you're like, I would like to go over one, I didn't get it right, please ask. All right, put in your chat box. No questions? No for no questions? All right, we're gonna move on then. All right, for today, I'm gonna go ahead and pull up our assignment. Okay, you guys will, on your Google Classroom, you should have saw here, I'm gonna pull it up again soon so you can see. Do you see how it says questions on homework? We went over those. Number 2, it says book work, workday. Today's homework is pages 487 to 490. And these are the problems you need to do. We're gonna do some of these in class today. So you'll be able to have some answers right off the bat. So you guys can work along with me. So grab out your book or online and get those pages popped up. And I'm gonna go ahead and share this to my Smart Notes. Oh, I think it saved the wrong one. Hold on a second. Okay. Here's our problems we're going to start. We're going to start on number 9. So if you want to go start right there. The question is, we need to find sine of theta and cosine of beta. So Rowan, how would you find sine of alpha?
Sine of alpha.
Mm-hmm.
Sine of alpha would be wait, I'm trying to see. It's not real big on the screen.
You can get your book out. It's on it's the exact same problems as your book.
What page is it?
Page 487.
Okay. All right. Wouldn't it be like 3? Since like it only gives you 3 and 5, so don't you have to find the hypotenuse first?
Excellent. Good. I'm glad that you caught that right away. So how are we going to do that?
5 squared plus 3 squared. And then it should be, I think, is it like 34? And then the square root of 34? Or am I?
You're good. You're good. Okay, so you have 34 here, and then the square root of 34 is the square root of 34. It doesn't reduce down. So, okay, so back to alpha then. How would we find that?
It is 3 over the square root of 34.
Great. And you guys, you could go ahead and leave it like that. I know usually we talk about radicals cannot be on the bottom, but for today's homework, it's good to leave that way. Just as we flip it, it makes it a lot easier. So just leave it right now.
Excuse me.
Yeah.
Xavier texted me. He said his internet went out, so I think he left. He's gonna try to get back in, but this happens quite often sometimes.
It's okay. I'll write a note. Thank you. All right. My next question is for Kale. Kale, how are you going to find beta? Sorry, cosine of beta. Let's be a little more detailed here. Cosine of beta. Are you there, Kale?
Oh, sorry.
That's okay.
Wouldn't it be like cosine of beta equals 5/3?
Now remember, cosine is adjacent. So look at your beta right here. What's adjacent to it?
3. It should be 3 over radical 34.
3 over the square root of 34?
Yeah.
Interesting, you guys. Let's look at this. This is the same as this. We're just going to keep that in note, this something to observe for a second. All right, we're going to go ahead and move on to B. All right, Grace, how you find tangent of alpha?
Wouldn't it be 3 over 5 because it's opposite over adjacent?
Excellent. All right, and then cotangent, I'm gonna have Aubrey do it for us. How you find it, Aubrey?
Isn't it adjacent over opposite?
Okay, so what is it?
Oh, 5/3.
Hold on. Cotangent, right? But you're talking about cotangent of beta, not of alpha. So you have to think you're back here at beta, and your tangent is opposite over adjacent. But
So
go ahead.
3 over 5.
There you go. Great job. All right, let's go on to C. Oh, hold on. Let's observe this here. Look, these are the exact same. Very interesting. All right, let's go to C. Secant of alpha. Cody, how you find secant of alpha?
Hypotenuse over adjacent, which is radical of 34 over 5, right?
34 over 5?
Radical, like, or square root.
Okay. Great. And then cosecant. Let's have April do that one.
It's radical 34 over 5 as well.
Interesting. So if you guys notice, we have, oh, sorry, I meant not to make that 34. These are the exact same thing. So just some terminology here to think about. These are called co-functions. Okay, and the way to help you remember it is complementary angles. If you guys remember that word from geometry, they add up to be what? Does anybody remember what complementary means? Colette, do you remember what complementary means?
Sorry, my thing wasn't working. It means that they correlate to one another.
Okay, what do they add up to be?
90.
Yes, yes. So if you guys think about this, if you look at these two angles, because we already know this is 90, these two are always going to add up to 90. So they are complementary. So cofunction, complementary, they both start with C, might be a good way to remember it. So alpha and beta, oh, sorry there, are complementary angles and they're cofunctions. So just some terminology to remember for if I ever use it in class, you know what it means. All right, we're gonna go ahead and move on to 19. And Mason, you're gonna help me out. We need to find on 19 our unknown. What is our unknown?
So we have our angle down there, and we need to use like the opposite and adjacent. So it's going to be tangent.
Okay.
The tan of 36, and then that would be 12 over x.
Okay, how are we gonna solve for the x?
You could multiply the x on both sides, and
Yep.
then put the 12 over tan of 36, like divide the tan of 36.
Yep, You got it. I'm gonna go ahead and show the work. You guys can do it at home and get the answers while I get this work down. Remember, your mode needs to be in degrees. If it's not in degrees, you will not get the right answer. All right, so we should get 16.52 degrees. All right, that one's done. All right, keep going. Number 21.
Would that be degrees, or would that be like a?
We'll just say again, Mason.
Would that be degrees, or should it just be like a measurement?
Thank you. I didn't mean to put degree on there. Thank you, Mason. All right, 21. And all right, it says we need to express X and Y in terms of trig ratios. I want you guys to make sure, those of you maybe jumping ahead and working ahead, pay attention to this one because it's just a little different in the answer. And I can see you guys totally writing the answer and thinking you're done, you're not done. So let's just, Matt, why don't you help me out here? How do we find, I want you can pick X or Y, which one you want to solve first?
We'll go with X.
All right, sounds good. How are you going to solve for X?
Could you use like the 90 degrees as your angle? And then you could do
And then what?
And then you could use like the 28 as your hypotenuse. So
Yes.
that'd be, cosine would to solve for X, so it'd be adjacent hypotenuse.
All right, so we have cosine of theta equals, he said, our adjacent over our hypotenuse of 28. Now, you guys probably be like, I'm done, I'm good, I have wrote a formula, but it says express X and Y in terms. So we need to solve for X. So how would you solve for that, Matt?
Multiply each side by 28.
Yep. There's your answer. You can write like this. Some of you guys might like seeing it like with parentheses. It doesn't matter. Either way is fine. All right, let's look at Y now. Christina, can you help me on Y? How do we do Y?
So you would take the tangent of 36.
Okay, hold on. Where's 36 coming from?
Oh, sorry, I was in the wrong problem. I mean 20, you would set cosine of angle is equal, sine of angle is equal to y over 28.
Yes, sine, maybe correct yourself. Sine of the angle is y over 28. And then how are we gonna get rid of that 28?
You would multiply it to the other side.
There you go. And that one is done. So if you guys have noticed, we're doing about one from each section. So that should help you get your homework done, just knowing what you're needing to do. We're gonna go ahead and move on to page 2. Which is, we're gonna do problem 23 in your book. All right, it says sketch a triangle that has an acute angle. So I'm gonna go ahead and draw that up here just to make a right triangle. It has acute angle, we don't know it. And we have to find the other 5 trig ratios of theta. So read how you find, where are we gonna put these 5 and 6 at? Reed Andrews.
Since it's tan, it would be the 5 would be the opposite side, and 6 would be the adjacent side.
Great. Okay. So Reed, I need the other like answer. So which one would you like to try to find?
Well, we need to find the hypotenuse, right?
Great. All right. So how you gonna find that?
Pythagorean's theorem.
Mm-hmm. So talk me through it. What are you gonna do?
So 36 plus 25 equals c squared, and then
Oh, sorry. I'm just gonna show that just in case anybody did not see that he took 5 squared, 6 squared, and gets c squared. And what did you get when you added those numbers together, 25 and 36?
hold on. 61.
Yep. So c is what?
Radical 61.
Yep. Excellent. All right, I'll ask another person a question. Let's go with Jacob. How are you gonna find the other trig ratios?
You would just plug those in.
Okay, how?
Do you want me to pick, what do you mean? Do you want me to pick a random one and tell you the
Sure.
answer? Okay. Ls to sine,
Okay,
and it would be opposite over hypotenuse, and that's 5 over the square root of 61.
yep. And we can leave it like that, that's fine. You guys do not need to change it. Max, can you give me another one?
Yeah, let's do cosine.
Okay, how are you gonna find it? Tell me what it is.
It's gonna be adjacent hypotenuse.
So what is
That's
it?
gonna be, 6 over radical 61.
Excellent. All right. Chloe, give me another one.
You could do cotangent, which is 6 over 5.
So I have a question for you, Chloe. How did you find 6 over 5? I just want to see your thought process behind it.
It's the inverse of tangent.
Yeah, so we already had this right up here. And so she just flipped it over. That's great. All right, Marie, what about you? Can you give me one?
Yeah. Oh, and it's also Murray, by the
All right, I'm gonna write that down. I need that. So
way. No problem. I don't think we've done secant, which would be the inverse of cosine, which would be radical 61 over 6.
all right. Emily, can you give me the last one we need?
Cosine would be, wait.
All right, what would it be?
Cosecant would be radical 61 over 5.
Radical what? Sorry.
61.
Yep. Over what?
Over 5.
Yes, sorry. You're quiet, so I had to listen there for a second. Great job on that one. This is probably pretty easy for you guys to find those ratios. 29 is a little, it makes you think a little more. So let's look at 29. It might be helpful for you guys to think about the unit circle on this one. Oh, that's a great drawing, sorry. And this is our angle, and this would be pi over 6. So if you remember from our unit circle, there is a point, and our point is square root of 3 over 2.5. So think about this as a triangle. I'm going to draw a line here. If this is our point right here on the circle, and this is our origin of 0, okay, how long is this side? Reed Patterson, wait, how long is that side?
Which side?
We're looking at this side right here. I'll put it in a different color for you. I'm gonna make it green.
Isn't that one 3 pi over 2?
Yeah, 3 pi over 2?
Or radical 3 over 2.
Okay, sounds good. All right, so this is pi of 3 over 2. Sorry, it's hard to write on that. And then let's look at, Reed, let's look at our other side right here. How long is that side then?
Just 1/2.
Mhm. So just remember, this is your X and this is your Y. This is your X side, this is your Y side. So let's look at sine, and sine of pi over 6, Reed. When you think about sine, what are you gonna look at first?
Isn't the sine just the y coordinate?
Yes, and why is it only the Y coordinate?
Because the hypotenuse is just 1.
Yes, great job. Okay, so what'd you get?
1/2 plus radical 3/2.
All right, and can you go ahead and combine that for us and see what you get?
1 plus radical 3/2.
Yes. All right, there's one answer. Thank you. All right, let's keep going. April. How do you find sine of 30 degrees? You can't use your calculator. You might need to think about this. What do you know about pi over 6 and 30 degrees?
Pi over 6, isn't that 30 degrees?
Yeah, you're right. So this is the same triangle we're looking at right now. Okay, so what do you know about sine of 30? Think about, this is your angle. I'll put it in a different color here. This is your angle. Okay. Think about what sine is. You should be able to get it from me.
So sine is y.
Yep. So what is it?
Then isn't that going to be the same as last one where it was 1/2?
Yep. Great. And I'm just gonna put this in parentheses because if you notice, there's no plus, minus, or division sign here. So it means it's gonna get multiplied. Okay. So keep thinking here, April. I have cosecant.
Isn't that 1 over y?
1 over what?
1 over y.
Yeah. Okay, what is y though?
Y is 1/2.
Okay, you're doing great. How do you find this?
You can multiply them together.
Okay, great. Let's pretend we didn't have a calculator, April. What do you know about this? 1 divided by 1/2. Think about, like, if I have a fraction, a 1 times 1/2, 1 divided by 1/2, I take the second fraction, I do what? Multiply by the
reciprocal?
Yep.
So you would get 2.
Yep. And so your answer is?
It's going to be just 1.
Yeah. Great job. All right. And let's look at number 31. You notice on 31, there is 60 degrees now involved. Where would the 60 degrees be?
Well, wouldn't it just be like at like the second 6 like interval of a circle?
The second what? Sorry, say it again.
I'm trying to find my unit circle, but like
okay.
it's like the like the one after, it's obviously double the pi over 6.
You're right, but now I want you to think here, just you're right, it is double. There's a couple different ways to do it. You could go ahead and redraw it, or you could think too, April, just think this is 30 degrees. So then what's this angle? If this is 30 right here, what's this angle right here?
The 30, 60, 90 triangle.
Yes, yes, yes. So you can use the exact same triangle and say time, or you're right, you could go your unit circle and look at 60. That both are correct. Okay, so do you know what sine of 30 degrees is?
Yes, that's 1/2.
Okay. All right, what's cosine of 60 degrees?
So I'm sorry, I don't know.
Okay, there's two options. You can look at this triangle and make it it might be a little ugly that way, but you could do it still. So if I look, this is 60, and I think adjacent is a half over my hypotenuse. I could do it that way. So a half over 1, what do you get?
So wait, so you said you're taking the 1/2 and you're dividing it by 1?
Yeah.
Wait, wouldn't that just stay the same?
Mm-hmm. Great job. Because adjacent is a half divided by 1 is just a half. All right. All right, let's look at the next one. Sine is 60 degrees. What do you know about sine of 60 degrees?
So
You can look right back here at this triangle if you want and think, what does sine mean?
well, sine is opposite over hypotenuse.
Okay, so the opposite is what?
Which red dot are we looking at?
Oh, I should probably, how about I write it up here for you? Would that help you? 60 degrees is right here and 30 degrees is right here. Does that help you?
Yes.
Okay.
Thank you.
Yeah, no problem. All right, so this is 60. So we're looking, you said to do opposite over hypotenuse. So what'd you get?
Radical 3/2 over 1/2.
So reduce that for me.
It would be 1, sorry.
So it'd be the same, right?
Yeah.
Yep, great. All right, keep going. What do you know about cosine of 30?
Cosine of 30 is just 1 over 1/2.
Hold on, look at your 30. Okay, think cosine is adjacent.
Oh, sorry. I thought the other problem in front of it said cosine.
It's okay. You have to keep thinking. You're switching around your angles there. So go ahead. What'd you get?
So cosine would be adjacent over hypotenuse. So it would be radical 3/2 over 1 again.
Yep, and it's going to stay the same. Great. And a half time is a half.
Huh?
What's a half times a half?
Oh, 1/4.
Great. All right, now this is the hardest one. Radical 3/2 times radical 3/2.
Wouldn't that be like, it would just be like 3 over
3 over what?
4?
You got it. All right, add the fractions up and reduce for me, and what do you get?
So it'd just be 1.
Excellent, great job. All right, you guys, we are starting to run out of time. You guys want to pick the last one to do? So I had 3 more I wanted to get done in class. Do you want to quickly pick? If not, we're just gonna do 39. So I'm gonna do 39 or 47 or 53 in class. 53 is pretty easy, but I will tell you right now, you need to change it to feet. Make sure you change it to feet.
Can we look at 47 on your?
Yeah, great. We'll start that one. All right. So 47, it says find x round to 1 decimal place. All right, look at this triangle and think about what you know. And you guys can brainstorm here. What would you like to find first? So Andrew, what do you think we should find?
Maybe one of the other side blanks.
Okay. Like which one are you talking about?
I guess you could do the hypotenuse.
Now, it's not a bad idea, but I would like to save time. Think about, we need to find x. Okay, look at this 30 degrees. what do I want to find from 30? Do I want to find the side adjacent, opposite, or hypotenuse to help me find x?
Adjacent.
Yes, I'm gonna just call this adjacent side A. All right, Andrew, tell me how to find A.
Well, you would do from there, you would do tangent.
Yeah.
So it'd be tangent of 30 is equal to 100 over A.
Okay, how you solve that?
You would multiply by A and then divide by tangent of 30.
Excellent. All right, go ahead and do that. I'm gonna do it over here. Oops. All right, I got 173.21. All right, I have A. You guys might want to think, what else do I want to do to save some time? What do I want to find next to help me find X? So, Alexander, what do I need to find next?
Probably like the adjacent side to the 60-degree angle.
Yes, great call. Okay, so let's just call it B. All right, tell me how to find it.
Tangent 60 equals 100 over B.
All right, keep going. How you find it?
Multiply both sides by B and then divide by tangent 60.
Great. All right, quickly, those two, A and B, how would you, Anne, what would you do with those two numbers?
Did you say and?
Yeah.
Oh, you just add them together.
Yep, just add those two numbers together. I'll give you the answer since we are out of time, 230.95. All right, so this is due tomorrow, by tomorrow. So make sure you get it done. And if you have any questions, you can email me and I can set up a Zoom session with you if you need any help. So have a great day, you guys.
Did you see that I resubmitted my homework?
Let me, how about this? I will double check, make sure. So do you know what number it is?
Yeah, let me check. It was, I think it was 072 Monday, January 4th, 21, section 61, day 3.
Yeah, what number is that number right before it? I think it's like 71 or 72, one of those.
72.
What was it?
72.
Okay, how about I will check it and I'll email you once I make sure I have it. Does that sound good?
Yep.
Okay, thank you.
Yep.